Hi everyone, welcome back to PolyCloud YouTube channel. In this video series, we are covering the Microsoft Azure Administrator, that is AZ-104 certification, one of the most in-demand cloud certification in the industry. I will walk you through every Azure services from virtual machine storage and networking to identity management, policy and cost optimization with real hands-on demos and clear explanation. Complete series is designed to help you understand core Azure concept in depth, master real-world administrator tasks, prepare confidently for AZ-104 exam, and build a strong foundation for your cloud career. The best part is this entire course is completely free of cost, available end to end here on PolyCloud. I will also be uploading more Azure and DevOps and cloud courses soon. So please support the channel by subscribing and helping us to reach our first 1000 subscribers. It really means a lot and keeps this free learning going. Let's dive and explore Azure one service at a time right here on PolyCloud.
In this demo, I will be resizing a virtual machine. We know that sizing really refers to the underlying horsepower in the VM. It means the number of virtual CPUs, the amount of RAM, the number of data disks that can be attached. You can set the size when you're creating a VM. So if I click Create a Resource here in the portal, and if I were to step through the motions of creating a virtual machine, down below, besides specifying the virtual machine image, we would also specify this. There's a standard default size selected for this image, in this case with one virtual CPU and 3.5 gigabytes of memory, along with a cost per month if it were left running 24/7. If we open the drop-down list, we could also choose See All Sizes. So usually what's of primary interest for technicians here is the number of virtual CPUs, depending on the type of OS and the workload that will be running in it might dictate you need more compute power, the amount of RAM, the number of potential data disks that can be attached to the VM, the maximum disk IOPS, the input-output operations per second, is a measure of disk subsystem throughput. More is better. And also, of course, the cost per month. As would be expected, more horsepower means a lot more cost per month. So more virtual CPUs, more RAM will cost more than smaller variations of those items. Now, we could set this, of course, upon creation, but we can also change it after the fact, because the reality is, if you are monitoring a virtual machine, let's open up an existing VM just to open it, its properties. So running on the overview page here over on the right, we can scroll down. We can go to monitoring. There are other ways to monitor the VM. And down below, we have some standard performance metrics. Things like the CPU average utilization on that VM, which here doesn't seem to be going above 30%. The amount of disk read and write bytes. So usually, either the performance has degraded so badly, users will let you know, or you might be monitoring things proactively to decide, okay, it's time to resize the VM. And it's not just to increase the power. Maybe you over-allocated resources when you deployed the VM, and when the workload is running for an extended period of time, and you set a baseline for performance, you might realize, oh, I don't need that many vCPUs or that amount of RAM, even during peak workload conditions. So you can scale up by adding power vertically. You can scale down by reducing things like the vCPUs or the amount of RAM. So for an existing VM, and that's what we're looking at here, in the left-hand navigator, I can scroll down under Availability and Scale, where I have Size. I'm going to click Size, shown here at the top under the label Current Size. Of course, if we wanted to change up the sizing, then we could do that here. So maybe I'll switch to something that's got 2 virtual CPUs and a bit more RAM, and I'll click the Resize button. Now it says if the virtual machine is currently running, changing the size will cause it to be restarted. So this is something we want to do during off-peak hours, of course. In this case, because it's just a test VM, nothing is at stake, so I'm going to click Resize to have it happen right now. And up in our bell notification icon in the upper right, it's in the midst of resizing the virtual machine. Okay, and after a moment, the virtual machine will have been resized. So now, under current size, it's showing a standard underscore B2S, and that's what's selected down below. So now the number of vCPUs and the amount of RAM have been increased. that will be reflected in the virtual machine itself. Let's go check it out. I'm going to go ahead and click Overview on the left, and I'm going to choose to connect to this virtual machine, and I'll choose Connect via Bastion, and I'll choose Deploy Bastion. Now, the reason I've chosen to do it this way is because if we check out the network settings on the left for this VM, it does not have a public IP address. So, if it doesn't have a public IP, we can only connect to its private IP to manage it, whether it's through a site-to-site VPN or an express route circuit, or in our case, using Azure Bastion as a jump server. All right, let's go back to the overview page and let's click Connect via Bastion. I'm going to use VM password as the type. The other choice there is from a key vault, but I don't have a password stored there. So I'll specify both the username and the password. It's going to open a new web browser tab. Okay, I'll choose Allow to see text and images copied to the clipboard. And here in my remote session, I'll right-click on the taskbar and choose Task Manager. I'll click More Details, just maximize that. And I'll click the Performance tab. Notice that it's showing over on the right that we have 2 virtual processors. And for memory, that we've got 4 gigabytes of memory. So to the OS, it just sees more hardware. It's no different than if you were running a virtual machine on premises, VMware or Hyper-V, and you increased the amount of virtual hardware. It's precisely the same thing here. Another quick note here, if we go into Cloud Shell, then I'll switch over to PowerShell. If I were to run git-command *resize*, notice we don't have a resize type of commandlet, at least not a commandlet with the word resize in it. So how would you do that? If you take a look at the online Microsoft documentation, if you take a look at the online Microsoft Azure documentation, it won't take you long to determine that the correct commandlet is called update-azm. So back here in PowerShell, what we could do is create a variable such as myVM, which would equal get-azvm-resource name, let's say HQ-VM name, serve 2022. We could then do the following. We could check out which properties are part of that virtual machine variable. So $myVM pipe get-member-type property. Notice that we have a property here called hardware profile. So if I were to bring back that previous command, but instead change it to $myVM dot hardware profile and pipe that to get-member type property, notice it returns back the VM size in conjunction with the update-avm, because you specify your virtual machine variable when you do the update of the VM, would allow you to change the VM size in PowerShell. In this demonstration, we're going to take a look at how to configure Linux SSH Public Key Authentication. Now, public key authentication means that we have a public and a private key pair. This would be designated for each user that needs to remotely manage a Linux host. So each user would have their own unique key pair. Now, in Azure, you can import key pairs you already have, or you can have them generated in Azure for this purpose. Public key authentication allows you to have another factor of authentication instead of just username and password, which constitutes something you know. You would have the username, which is something you know, and the possession of the private key, which is something you have. So, two-factor authentication. So we know that we need a public and a private key pair then, that's unique to the user. The public key is stored with the Linux virtual machine in the Azure cloud, but the related private key would be stored on the user's management station. And the private key, of course, as its name implies, needs to be kept private and should be backed up frequently. Okay, let's examine. When we go to create a new virtual machine, so here in the portal, I'll click Create a Resource. I'll choose Virtual Machine. And down below, notice that Ubuntu Server is selected. If I scroll further down, the default authentication type when you deploy a new Linux VM is SSH Public Key, as opposed to just username and password. SSH Public Key, you still need a username, but you can determine if you want to generate a new key pair, use existing keys stored in Azure, such as in a key vault, or use existing key stored in Azure. That would be a public key perhaps already stored with another Linux VM that you have access to. Or use an existing public key. If we choose use existing key stored in Azure, we would select it from the list, but I don't have any yet. We could choose use existing public key, which we would then paste in. But you can also modify an existing virtual machine to use public key authentication. I'm going to go to the virtual machines view in my left-hand navigator. I already have an Ubuntu server. So I've got a Linux host. If I click on it, and if I scroll all the way down, towards the bottom in the left-hand navigator under the help section, we have reset password. Now, because the VM is not running, it tells me you need to have the VM running for this to work. Okay, let's go to overview, and I'll click start to start the VM. Now that the VM is running, I'm going to go ahead and go back down to that same place. I'll click reset password on the left, and this time we can reset the username and the password if we choose reset password up above. But this was deployed by another technician that's no longer with the organization, and you don't know the credentials. But you can also add an SSH public key. Now, this virtual machine was deployed with just a username and a password. So when I go to add an SSH public key, I get to specify the admin username for the VM operating system. And then we have the same options that we saw when we were deploying a new virtual machine. So generate new key pair, use existing key in Azure, use existing public key. I'm going to tell it to generate a new key pair. And that key pair name will be called cblackwell-key pair. And I'll choose update. So now I need to download the private key portion of that key pair. So I've got a key pair file available here. And of course, the public key is stored with this virtual machine in the Azure cloud. I've navigated to putty.org in my web browser because I've downloaded the free PuTTY tool, which is commonly used for remote SSH management, and you can specify an SSH private key to use. One of the tools that gets installed when you do download and install PuTTY is the PuTTY key generator. You need to make sure that file is in a format that can be used by PuTTY. So I'm going to choose the load button, and I'm going to open up our cblackwell key pair file. What I'm going to do now, I'm going to specify and confirm a passphrase. Key files that contain private keys should always be protected with at least a strong passphrase. And then I'll choose Save Private Key. And it's going to save this as a PuTTY private key file, which ends in .ppk. Save. And I'll close the PuTTY Gen tool. Now I'm going to open up the PuTTY tool, and I'm going to fill in some details here. Basically, I'm going to save a profile for connecting to my Ubuntu server virtual machine. So I'll open up its properties and go to network settings on the left. I'll click on its public IP address resource, and I'll actually copy the public IP. Back here in PuTTY, I'm going to specify that IP address, port 22 SSH, but over in the left navigator, I'm going to go down under connection SSH and auth. And here I can specify the path and file name for the private key for authentication. So I'm going to select our cblackwell private key file that we just converted and saved. And I'll go back up here to session on the left. I'm going to call this Ubuntu Azure, and I'm going to click Save. So I don't have to specify all these details again. Okay, let's try it out. Let's open the connection down at the bottom. Well, it's prompting me to log in. That's a good sign. cblackwell is the username. Enter. But instead of the password for cblackwell, what it's prompting me for is my passphrase that I entered when I saved the private key. So I'll enter that. And just like that, we are now authenticated to our Linux host using SSH Public Key Authentication. In this demo, we're going to take a look at how to manage virtual machines through Azure Bastion. Bastion is a jump server or jump box solution. And traditionally, what this has meant is that we have a server, a host, that has both a public interface and a private interface. So kind of like a router or a firewall. Except its role is special. By allowing connections on the public side to the server itself, but not through it, so no IP routing on the host, that host in turn, can be used as a launching pad to remotely manage internal hosts through the private interface using private IPs. And that's really one of the primary benefits of Azure Bastion. It lets you remotely manage virtual machines in Azure without them having a public IP. If we go to the All Resources view here in the portal, and if I change type equals all, and I select network interfaces, so we're filtering only for network interfaces. Here we've got network interfaces tied to virtual machines. If I were to choose a particular network interface for a virtual machine, it's also got an IP configuration, such as whether IP forwarding is turned on. If it's got multiple network interfaces, perhaps it's a firewall appliance. And down below, we've got the IP config for that network interface, where it has a public IP address object that's a separate resource in the subscription associated with that network interface, and ultimately, of course, with that virtual machine. Having a public IP address does make the virtual machine publicly visible and potentially open to a variety of different types of attack attempts. So unless your virtual machine has a specific reason it needs this kind of public visibility on the internet, and that would be rare generally, really, they shouldn't have public IPs. A VM should have a private IP, and that's it. You either come in through ExpressRoute, through a VPN connection, or through Bastion to manage it using its private IP. In my virtual machines view, I've got a server called WinServe 2022-2. It's up and running in the East US location. If I click on it to open up its properties, we can then click Network Settings on the left to check out its network settings. So, of course, it's got a network interface, it's in a subnet, it's got a private IP address, but it does not have a public one. So how do you get to that private IP? Well, we've mentioned a variety of ways, including through Bastion. So what I'm going to do is go to the overview page of this virtual machine, and I'm going to choose Connect. Now, we could do a standard Connect using native Remote Desktop Protocol, or RDP, and download the RDP file. But the problem is that RDP file is going to have the private IP address embedded within it. Well, you can't connect to that over the internet. So I'm going to go back to Overview. I'll choose Connect again, and this time I'll choose Connect via Bastion. If it's already configured, we'll be prompted for credentials. But because we did not get prompted for that, it is because there is not a Bastion configuration in that. Now, it makes a suggestion for what it will call the configuration and the resource group it will be in, and for which virtual network. You could configure everything manually. You can configure Bastion outside of doing it the way we are here by launching it within the virtual machine properties. But at the end of the day, you end up with the exact same thing. So Bastion is actually a resource that'll show up in your subscription. Let's go ahead and just choose Deploy Bastion with the default selection. You can monitor this in your bell notification icon in the upper right. So it's currently configuring Bastion. That'll take a few minutes, so I'll just wait until that's done. All right, and after a few minutes, it will have created the new Bastion configuration. So the screen is still open here in the background. This is what it looks like when you connect via Bastion to a virtual machine. You can specify the keyboard language, the authentication type like virtual machine or VM password, or you might have it retrieve a password from an Azure Key Vault. But in this case, it's just going to be the password I enter here. The username for the admin account in that virtual machine OS, I'll put in the VM password. And remember, if the VM password is forgotten or the previous admin that deployed it didn't tell you what it is, you can just scroll way down on the left under the help section and click on Reset Password. And it's going to open this up in a new web browser tab. All right, let's click Connect. It asks if we want to allow the virtual machine session here, the remote management session, to see stuff that we put on the clipboard. I'll choose Allow. So it remotes me directly into that virtual machine where it looks like whoever was previously here had the task manager up and running. But we are actually in a web browser window managing our Windows host. The great thing about this is we're doing it with that virtual machine only having a private IP address. We didn't have to set up a VPN tunnel or anything like that, although that's valid too. So on my computer, if I were to copy something, let's say I copy some text on my local computer, If we go back into the Bastion session, when I click the icon here, the little chevron icon, the two arrows on the left, notice that whatever was in the clipboard that I copied locally is available here in the remote session. Back in the Azure portal, let's navigate over here to the All Resources view, where I'm going to filter the list for Bastion. Notice that we have a resource of type Bastion in the All Resources view. If I click to open up its properties, it's deployed in the East US location. If I click on Sessions, any current session information for people connected via Bastion, of course I'm still connected in this other window up here, but it will be shown here for the target host name, the username, the target private IP address, the protocol, whether it's RDP or SSH for Linux. If I click Configuration over on the left. So back in our virtual machines view, that's in East US. So therefore, if I go to another host, let's say Linux, let's make sure this works with Linux. If I click Connect via Bastion, well, this time it didn't prompt me to authenticate. Well, the reason is that even though these virtual machines are all in the same region, they're in different VNets. This is in a VNet, which we'll just check over here under network settings on the left, called HQ_VNet subnet 1. Well, that's different than the server that we were looking at. It's in VNet 1 subnet. If I go to another virtual machine in VNet 1, well, when I go to overview here, connect via Bastion, it will use that configuration. Because remember, it's configured for a VNet 1. If we go back into the overview page of our Bastion configuration, over on the right, it's tied to its own specific subnet created for Azure Bastion that happened in the background. It's also got a public IP address, which allows connectivity in the first place. I'm going to go into another virtual machine here that's in VNet 1, but a different subnet. So I'll go to Network Settings. This is in VNet 1, Subnet 1. This virtual machine will still be able to use that configuration because it's still in a subnet under VNet 1. So if I go to Overview, connect via Bastion, once again, we're prompted to authenticate. Okay, in this demo, I'm going to be working with managed disks. A managed disk is a virtual disk. It's a resource that you can create in your Azure subscription. Of course, you can create many of them. And the virtual disk, the managed disk, can be associated with virtual machines. Let's take a look at our virtual machines view as a starter. I'm going to open up an existing Windows Virtual Machines property. I'm going to scroll down under Availability and Scale, and I'm going to click Size. Now, I'm doing this because the virtual machine size, of course, determines the number of virtual CPUs, the amount of RAM, but also the maximum number of data disks that can be attached to the virtual machine. Depending on what your workload requirements are, depending how many different disks you might anticipate adding, can influence your choice on the size. And of course, you can change this after the fact if, for example, you only had support for 2 data disks and now you need support for 4. You can change the sizing if you need to. But bear in mind, changing the size of a virtual machine will restart it. While we're here in the properties of this virtual machine, we can go to Disks over on the left. This is going to show us the current disk configuration for the VM. Of course, we have an operating system or an OS disk. The size is shown here, 127 gigabytes. The maximum input-output operations per second, or basically disk bandwidth, throughput, is 500. A higher numeric value is always better for disk performance. But down below, if there are any data disks for this VM, they would be shown. Now we have 2 options at the bottom. We can create and attach a new disk, so we can do it all here at once. Or if we've created the managed disk resource outside of the virtual machine, so it's just a resource in our subscription, then we could attach it. In this case, we're going to choose Create and attach a new disk. So we've decided, hey, I want a new disk for this VM. Now, adding it here is only one half of the equation. The second half involves going into the virtual machine operating system and using whatever tools you would normally use to initialize the disk, to partition it, to format it, whatever it is you need to do to it. Okay, so let's create and attach a new disk. So it's going to have a logical unit number or a LUN of 0. That's fine. I'm going to call this Win Data Disk 1. For the storage type, I'm going to leave it on premium SSD solid state drive, as opposed to going down to something like standard hard disk drive, the older traditional hard disks that if you've been working in this industry long enough, you'll definitely recall spinning rigid metal platters encased in a vacuum sealed disk drive. Anyways, I'm going to leave it on that. For the size, I'm going to make it 10 gigabyte. That is ridiculously small for today's. That's pretty small by today's standards, but for this example, it'll do just fine. Over on the far right, for encryption, it's going to be using a platform managed key. That's fine. Okay, I'm going to click apply. So if I look at my notifications, notice that it successfully created the disk and updated the virtual machine. Well, that makes sense. So Win Data Disk 1 is showing up here. It'll also show up, of course, if we go to the All Resources view. So here, I'm going to change the type equals all filter, as you might guess, to only disks. So let's apply it. So there's Win Data Disk 1. Of course, we've got other disks that are used for other configured services, other virtual machines. If I go into the properties of Win Data Disk 1, notice that I can create a snapshot of it, a point-in-time picture of the state and the contents of that disk right now. Notice over on the right under Managed By, it says WinServe 2022-1. That's the VM it's associated with. If I go over to size and performance, notice that I can change the disk to be much larger and also having a higher disk IOPS value for better performance. So I'm going to go back to my virtual machines because I want to manage that server so we can continue working with that disk. So in the overview page over on the right, I'll go to connect via Bastion. That's how this one's can specify the credentials to sign in. Okay, now that I've signed into my server, I'm going to Start menu and fire up Server Manager. I'm going to manage the disks in there. Click File and Storage Services on the left, and then I'm going to click Disks. Okay, so we've got our 10 gigabyte disk shown here, although the partitioning on it is unknown. It's basically a raw disk. So I'm going to right-click on it and choose New Volume. I'm just going to accept all of the defaults on this so far. So it's going to be brought online and initialized as a GUID partition table or GPT disk. Okay, that's what we want. We're going to use as much space as we can for the volume. Drive letter E, volume label I'll set as data 1, and I'll continue by clicking next and then create. So this is the exact same process you would go through if you physically plugged in new storage devices into a Windows server. All right, let's check this out now. So if we were to go into File Explorer on our server, as we might expect, we now have a data 1 labeled disk volume in the form of drive letter E. If I right-click on that and go into the properties, of course, it's approximately 10 gigabytes in size. In this demonstration, I'm going to be configuring encryption for a virtual machine disk. We're talking about encryption using 256-bit AES, or the Advanced Encryption Standard. In order for us to do this, there are a few prerequisites. One of them is that we need to have a key vault and a key in it. The key, of course, will be used for encryption. We then need to create a disk encryption set resource, and then we can associate a managed disk with the disk encryption set, and it will be encrypted. So let's take a look at this here in the portal. I'll begin by going to the All Resources view, where I'm going to filter it from type equals all to only showing key vaults. So I'll apply that. All right, there's a key vault. I'm going to click to open it up. And if I go to the keys view, we've got a key pair here called key pair 1. Now you can use that for a multitude of things. Use it to encrypt storage account with a customer managed key, which is what that one is being used for right now. You could use that same key pair for virtual machine disk encryption, or you could generate a new key pair. It really doesn't matter. We're just going to reuse the same key pair. So we know that that prerequisite is in place. So what's next? What's next is we have to create a disk encryption set. How do we do it? It's just another resource in the subscription. So we're going to choose create a resource here in the portal. And if I just search here for disk encrypt, there's disk encryption set. So I'll select that from Microsoft. I'll choose create. I'll deploy this into a resource group, and I'm going to give this disk encryption set. For clarity in this demo, I'm just going to call it disk encryption set 1. It will be deployed in the East US region. And for encryption, I want to make sure it's set to use encryption at rest with a customer managed key. I don't want a platform managed key, keys managed by Microsoft. So we have to select the Azure Key Vault and key, and that's what we checked out first a few moments ago. So from the drop-down list, I'm going to choose our key vault, within which I will then choose our key pair 1. We only have one version of the key, so I'll select that from the version drop-down list. I'll click Next Tags, nothing changing here. Next, Review and Create. And then I'll click the Create button in the bottom left. Okay, so if I click Go to Resource, our disk encryption set is good to go. But there's a note here. When I'm in the overview page, it says to associate a disk image or snapshot with this disk encryption set, you must grant permissions to the key vault. So in other words, we've defined that there is a key vault with a key in it that this disk encryption set should use. We have to make sure the permissions are in place so we can actually go and get the key and read it. So we're going to do that by going to the All Resources view again, and let's get into our key vault. So I'll just filter the list of resources. In the key vault, I'm going to click Access Control IAM on the left. I'm going to click Add Role Assignment. I'm going to filter the list of roles for the word key. I'm interested in the Key Vault Crypto Service Encryption User role, which will allow accessing keys stored in the vault. But to whom will I grant it? It's not a user group or service principal. It's a managed identity that represents that disk encryption. I'll click Select Members. For the managed identity, I'm going to choose Disk Encryption Set. There it is. So that was generated automatically for me. I'll choose Select, Review and Assign, Review and Assign. Okay, so now the disk encryption set is allowed to come in here and allowed to go in and look at keys. That's kind of important since it needs to use that key for encryption. The last thing that we need to do here is to associate our disk encryption set with a managed disk. It could be an existing managed disk. It could be a new one. Just for fun, let's create a brand new managed. So I'll search for managed. I'll choose managed disk, managed disks, and I'll choose create. I'll deploy it into a resource group. We call this data disk 2. It will be deployed in the East US region. I'll leave the sizing as it is for it. I'll click Next. Currently, for key management, the default selection is Platform Managed Key. So what we want to do is change that. Under Customer Managed Key, you should see your disk encryption set. If you don't, and sometimes you won't if you do this right after creating it, it's just a matter of time and waiting for it to refresh. I've had cases where even despite the fact that I refresh my web browser or exit out and come back in, it still doesn't show up and it takes a few minutes. So be patient if you know you've done it correctly and it's in the same region. So I'm going to select that disk encryption set. I'll click Next for networking. I'm not worried about public access to this managed disk. That's fine as it is. Everything else is good. So basically, I'm just going to create the managed disk. It's going to use that disk encryption set for encrypting it. Now that's making a new one. Why don't we go take a look at an existing disk? So if I go back home, let's say go All Resources, I'll change Type equals All to Disk. I'll apply it. I've got a Windows 11 virtual machine disk here, so I'm going to click on it and go to Encryption. So in the same way, it looks and feels like the same type of interface. I can simply switch it to Customer Managed Key, select my disk encryption set, and save. If we open up our notification bell icon in the upper right, it has successfully deployed our managed disk using our disk encryption set. It also successfully applied our updated configuration for our existing Windows 11 managed disk by using the disk encryption set. In this video, I'm going to be working with the virtual machine scale set, otherwise referred to as shorthand as VMSS. A virtual machine scale set uses the same virtual machine OS image, so they need to be similar, whether it's a marketplace image or a custom one that you've created. But the great thing about a scale set is, as the name implies, it allows you to configure auto scaling, and it can even be used as the backend for a load balancer. So let's take a look at how to build a virtual machine scale set. In the portal here, as usual, I'll start by clicking Create a Resource. I'm going to type in VMSS in the search field, and I'll choose VMSS, Virtual Machine Scale Set. So I'll select that offering from Microsoft, and then I'll click Create. We're deploying a resource in the subscription, so you must specify the resource group where it will be deployed and give it a name. I'm going to call this VMSS 1 for clarity in this demonstration. It will be deployed in the East US region. You can use the flexible orchestration mode where you specify VM details. So you manually add the VMs to the scale set, or you can have Uniform do it for you. I'm going to choose Uniform. And then, of course, comes the image. What is it that we're going to be using here? Usually it would be a server-based image. So let's say I'll choose Ubuntu Server. I'll leave the default sizing for my Ubuntu virtual machine. For the authentication type, I'll just use password in the interest of keeping things simple, because the focus here is not on the authentication of Linux. I'll choose Review and Create, and then I'll choose the Create button. Before too long, the scale set will be deployed. So I'm going to click the Go to Resource link here, or the button, just to go into the properties of our virtual machine scale. First thing I'll do is click Instances. Notice that what it's done is it's started 2 virtual machines. The prefix part of the nomenclature comes from the name of my resource, VMSS1. So we've actually got 2 virtual machines here. Let's open up another window for the portal here, and let's go to the virtual machines view. Notice that they do not show up here. They will only show up here in the instances view within the virtual machine scale set. If I click on any one of those instances or virtual machines, it takes me into the settings for it where I can connect to it over RDP SSH or using Azure Bastion to manage that VM. I can look at its network settings, its disks. So it's really just another virtual machine, but it's tied to the scale set. What I'm interested in doing, though, is scrolling down on the left, down under Availability and Scale. I'm going to click. Now we can manually scale, which means determining how many instances we want, or we can do a custom auto scale, which I will select here. Then I'm going to go down, and I'm going to choose Scale based on a metric. In other words, when things get busy, we want to scale out horizontally. We want to add VM instances. So maybe the minimum is going to be 2, but let's say the maximum will be 4, and the default will be 2 instances. Above here, I'm going to click Add a Rule. I'll choose Virtual Machines, and I'm interested in the percentage CPU. There are other metrics that you could look at, but that's going to be the key indicator that things are getting busy and we need to click Add. Down below, it's set to be greater than 70% for up to 10 minutes of duration. Then that means that we are going to be scaling out. So that's fine. I'll click Add, and I'll click Save to save that configuration. Now we can also go to load balancing over on the left, because usually the scale set is sitting behind a load balancer. So client connections are funneled in through the load balancer to the backend scale set. So from here, we could choose to add load balancing. Or you could build a load balancer here in the portal, such as with Create a Resource. If I search for load balance, I can choose load balancer. So I'll choose load balancer from Microsoft, create. We're not actually going to step through that. So I'll just quickly choose a resource group, put in a name. I'll just add a quick front-end IP configuration. When I go to Next Backend Pools and I go to Add the Backend Pool, this is where I could click the Add button down under IP configurations and select my scale set. We'll be looking at load balancers in another demo. So, in this course, we've examined how to deploy and configure Windows and Linux Azure-based virtual machines. We did this by exploring how to deploy VMs using the portal, the CLI, and PowerShell. We discussed how to redeploy, how to move, and how to resize virtual machines. And we also configured SSH Public Key Authentication and managed VMs through Azure Bastion. We then attached a managed disk to a VM. We enabled disk encryption, we captured a VM image, and we created a virtual machine scale set. In our next course, we'll move on to explore how to deploy and manage cloud-based application containers.